Hello everyone and welcome again. Today in this tutorial we will give some introduction about the ESP8266-12E module Wi-Fi that we will use to connect our system to the internet. In this tutorial we will give some introduction and a basic starting setup. Okay, so first of all, the ESP8266 actually is a Wi-Fi module, come in different variety as you can see here. Let me open the pen. Okay, so pen, yes. Okay, it's come in different variety modules as we can see here. Okay, but in this tutorial we will focus on ESP12E, which is this one, or same like here. Okay, this is the top face and this is the bottom face. As we can see here, this module actually consists of, if I'm not mistaken, 22 pin. Okay, and also got a built-in LED here and also a built-in antenna. Okay, this module, the pin out of this module, the pin pitch actually is too narrow. I believe it's about 2 mm. The pin pitch, okay, for this module is 2 mm. So it's not really breadboard friendly. So we have to build what I call like adapter. So this adapter, it will adapt the module like this. Okay, so the top surface of the module will be soldered to the connector with 2 mm to match the module, and the bottom surface of the adapter will have, I believe, 2.2 mm to match with the breadboard. This one later we will talk about the adapter. Okay, so the ESP8266 and specifically the 12E Wi-Fi is developed, or mostly actually all of the ESP8266 is developed by the AI Thinker team. It's relatively small in size and encapsulates with the 10 silica L106. It's very ultra low power device that has a 32-bit MCU with 16-bit of short mode. The clock speed, it supports 80 and 160 megahertz and also support the real-time operating system, or the RTOS. It's got, as we said before, is on-board antenna plus LED or common lead. So later we will learn how to start to toggle this LED or how to use it. For especially, it's very important. I mean, useful for debugging or tax information. And also, a user can add module to an existing device or networking, or building a separate network control. Okay, the ESP8266 is a highly integrated wireless SoC system on chip designed for space and power constraint, as we say, because it's very low power and small in space, so it's very suitable for mobile platform designers. Okay, it's really low cost, it's not expensive at all, and as we said, it's too small. And here is the block functional diagram of the ESP8266-12E. Okay, the features of this module, it's support IEEE 802.11 PB/G/N. Later we will talk about these 3 shortcuts. And also is integrated with low power, as we said, integrated of low power 32-bit MCU. Okay, here. And also got 10-bit ADC. This all is built in. And also got the full stack of TCP/IP protocols implemented inside. So we can just use it, but we need to set the parameters for it, like say the source and destination IPs, etc., and the packets we need to send. And also integrate with the Wi-Fi MAC with BPRF PA and LNA. Also integrate with PLL regulators and power management units. Support a lot of diverse of the antennas, and also it works with 2.4 gigahertz and support WPA and WPA2. Also, it's got the STA, PA power, and STA with AP, which is the station, access point, station plus access. This is the operation mode. It supports station, or can set as access point, or you can set as both station plus access point at the same time. It's got a lot of peripherals that support SDIO 2.0, serial SPI, UART, I2C, I2S for audio, IRDA, pulse width modulation, and GPIOs. It supports STPC, MIMO, and also 2x1 MIMO. The deep sleep power, when you set the module to go for the deep sleep, it's consume less than 10 microamp, very low power. And also the power down leakage is less than 5 micro. Okay, and when you set it to the sleep mode or deep sleep, it takes about less than 2 milliseconds to wake up. And if you set it just for the standby, it will consume less than 1 milliwatt. Okay, and I can see it's a target also for industry level applications, since it works from -40 Celsius up to 125 Celsius. Okay, so now on the next slide we will learn more about the PGN of the IEEE 802.11. Okay, so from here, from this data sheet, we can see the different categories of the 802.11 protocols. So start from 802.11, then 11A, 11B, 11G, 11N, and AC. The current ESP8266-12E support the A. Sorry, no, it doesn't support A. It supports P, B, G, and N. So it starts from the B. Let me delete this. Can I delete? Yes. So it supports B and support G and support N. Okay. So we can see here from these three, it starts with a frequency band of 2.4 up to 5 gigahertz, 2.4 for B, 2.4 for G, and N support both 2.4 and 5 gigahertz. Okay, and the most important thing actually is the maximum data rate. For the B, it can go up to 1 megabit per second. For G, go up to 6 megabit per second. For N, can go up to 15 megabit per second if we go with 5 gigahertz. And also support CL in, CL out. CL in, CL out, but for the last one, the N support 4 multi-in, multi-out. And again, you can read the rest of the parameter, but the most important is the frequency and the baud rate, or sorry, not the baud rate, the data rate. These are the most important parameters, but you can pause and read the rest of the parameter. Okay, so this is the pin-out diagram for the module. So as we can see here, this is the built-in antenna, and this is the built-in LED here, and these are the 22 pin each with individual pins and the functionality. So we can see here we got the ADC pins, we got the PWM here. You can see this sign, it represents the PWM functionality, and also got the RXTX, where we will use them for communication with another serial or UART device. And also we got the MISO, MOSI, these are the SPI, and the rest of the interfaces. So this device or this module got different mode, whether it's the UART or the flash boot. Okay, these are the two modes. How to access these two modes? By controlling these three GPIOs. We can see here GPIO2 always high, GPIO15 always low, but the most important is the GPIO0. If the GPIO0 is low, we will boot as a UART, or we use it as a UART communication to boot under UART. I mean, we program it under the UART or talk to it under using the UART. If we set it to high, it will boot normally from the internal flash. Okay, and in this video we will see how we control this sequence. Okay, so let's move on. Okay, so now here we can see how to communicate with the ESP8266-12E using the Arduino Uno. So as we know that the Arduino Uno has an internal converter here that converts from the USB to the UART, and actually the UART will come all the way to here, and also for sure it will come to talk to the main MCU, but also we have these two pins. So if we short the reset, see this reset, if we set this reset to the ground, so this MCU will not talk anymore, will not do anything, or we can just upload an empty sketch. Again, MCU will do nothing. Then, but for sure the better method is to just keep resetting the MCU by connecting the reset to the ground. So the output of the RX and TX will be always, will not be interrupted by the function of the MCU. So the USB that come from the computer will always go through the converter and come to the RX, TX, and go to the ESP8266 directly without going through any interruption. Okay, so now we take the TX from the Arduino Uno, pin number 1, we connect it to the TX of the MCU, of the ESP. Now we take the RX, we connect it to the RX of the ESP. And for sure we need to connect the ground. This is the ground, we connect to the ground. Okay, and again this this module, the Wi-Fi ESP8266, it's work with 3.3 volts, but for the VCC, but it's not recommended to use the 3 volt from the MCU, because the MCU doesn't support enough current that's required by the module. So it's always a good choice to use external source to power the ESP8266. Then we use some filtering plus supporting capacitor with 470 microfarad. Okay, so as we can see here, this is the positive. We connect to here, and this is the where's the VCC? This is the VCC connected to here, all the way to the positive and go down to here. Okay, so this is the positive, and this is the negative, come from here, top. Okay, you come all the way here, and go to the ground of the ESP. Okay, what else? Okay, so to talk to the ESP8266, we need only these two wires, which is the RX and TX, plus the ground and the VCC from the external power supply. What else? We need the GPIO that we mentioned just now. Okay, so the GPIO 0 that we say is the important to flash or boot from the internal, we use it to boot from the internal flash, or use it as a UART that will talk from these two pins. Okay, so we bring the GPIO 0, we connect it to this button here. Actually, this GPIO will be always connected where? To the VCC, because this one, you see, through here, through this about 10K ohm, connect to the VCC. And this button, when we press to flash it, it will connect it where? To the ground. So the GPIO 0 will be always connected to VCC through this resistor. But if you want to flash it, we want to connect it to the Arduino using this RxTX, you need to press and hold the flash. When we press this, actually this GPIO 0 will go where? To the ground. This is the first one. Now we come to the reset. The reset, again, we take this reset pin, you see, connected where? To this button. Reset will be always connected through this resistor, again about 10K ohm, connected where? To VCC. If you remember, this is the VCC, or this is the 3.3 volt. Okay, we connect it to the VCC through this about 10K ohm resistor. But if you want to reset it, you press the button. This button will short this pin where? To the ground to reset it. Okay, we finish from the reset. Now we come to the chip enable. This chip enable, it's fixed. It should be always connected to the ground, connected to the VCC to tell the ESP that you are enabled. So we bring this one again, 10K ohm, we connect it to the VCC. Chip enable, from here, this is the green signal, we connect to the VCC. And GPIO 15, again, always connected where? To the ground. You see here, this one come here, again, another 10K connected to the ground. Okay, so that's all. This is the diagram that we use to communicate, or to let the ESP8266 talk to the Arduino Uno through the RX and TX. So now let's see how we will use the USB to the UART converter to talk to the ESP8266 module. Okay, so this is the USB to UART. This is the USB to UART. Sorry. You know what? You come here, erase. Pointer pen. Okay. So this port is this, and this is the 8266. Okay. And this one is the external power supply. Again, it's very recommended to use external power supply. And here the supporting capacitor, the filtering and supporting capacitor could be, here they use 100 nanofarad. If for me, I would use about 220 to 400 capacitor extra. Okay. So now let's start for the wiring of this ESP8266. First, again, the VCC. Connect to the VCC of 3 volt, 3.3 volt, and ground, connect to the ground. But again, it's very important, don't forget to add the capacitors. At the same time, the ground should connect also to the ground of the UART adapter. Now, GPIO 15, as we said before, it should be always connect to the ground through 10K ohm. Okay, and chip enable should be always connect where? To VCC to tell the module it's enabled by using 10K DC connected to the VCC. There's a chip enable. What left? Now we come to the RX and TX. The RX from the adapter, from the UART adapter, we connect it to the TX of the module. And the TX, we just cross it, connect it to the RX. Okay? Now, for the reset pin of the ESP8266, again, we connect it to the VCC through 10K. But at the same time, we connect the reset pin to the reset from the UART board if it supports RST. This one to automatically reset the board when we finish uploading the code. It's very important. So it will reset the ESP8266. Okay, and same goes to GBIO0. If you remember before, we use the GBIO0 here, this one, to manually press. If we want to flash it, we manually press and hold, then the IDE will able to talk to the ESP8266. But here we will do it manually because they have DTR. They connect the DTR to the GBIO0 directly, but we will pull it up to the VCC using 10K resistor. So this one will do everything automatically without any intervention from the user. But for me, for my board, I have added a reset button from here. I just took this. Let's add new color. Let's say this color. Okay, so I connect this to a button, and this button I connect it to the ground. So when this button closes, just reset the system. Then when release, it go back to the normal state. Okay, so for me, I will use this circuit and this schematics since I have this board, and it's can very easily integrate with the ESP8266 without using any manual buttons to flash or upload the code. So I will use this circuit. Later I will show you how to put it on the breadboard. And yeah, so we have reached to the end of this slide. So we will go to the breadboard to see how we have done the wiring for the ESP8266. Then we will develop the code, or the first step of the code, of how to trigger an LED, on how to maybe use a serial monitor, connect to the Wi-Fi router. We see what we can do in this first tutorial. Stay tuned.
Okay, so this is the module on the breadboard. I'm so sorry for the mess, but it's exactly I connected how I show you in the schematic diagram in the slide. So this is the module, the ESP8266-12E. This is the the USB to UART converter. This is the external power supply with the backup capacitor and filtering capacitor. Don't you worry to panic. Believe me, it just follow the schematics I show you in the slide. This is the reset button I add. So I connect the RX, TX, DTR directly to the ESP8266, and here's all the pull up, pull down resistors. Okay, and here's the reset button. So believe me, just follow the schematics, everything will be okay. So now we will go to implement the code, and we see how to run this module. Okay.
Okay guys, so now we will start with writing the code for the ESP8266. We will do very simple and basic code, where we will just blink the LED first, then maybe we try later to use the serial just to make sure that our circuit is working. Then in the future tutorial we will learn more advanced things with the ESP8266. Okay, so first of all, the first time you are playing with the ESP8266, we have to go to File, Preferences. Then we have to make sure that we have this link here. Okay, I will give you the link in the description down, so you can just copy and paste it first. It's very important, this one, to let us access to the ESP community boards that we will download later. Okay, we paste the link here. You will find it below. Then you hit OK. Then you will go to Tools, Boards. Then from the board, for sure here you see it's already downloaded, I already activated, but for sure you will not have this one in your own PC. So you have to go to the board manager. Okay, and from here, waiting it to download all the platforms. It will not really take a while, just a few seconds, or maybe up to a minute, depend on your internet. Okay, here we go, it's finished. Then you search for ESP community. Here we go, this ESP8266 community. Then you just install this this package. Okay, after you install this one, then you will go to your board, Tools. Okay, I guess mine is hang. Okay, here we go. You go to Tools, then you will see down below here all the ESP related boards. Okay, so let me select Uno first. So since we are using, as we said before, we use the ESP8266-12E. So from the board, we will go down and select the Node MCU 1.0 ESP12E module. This one is the one that's compatible with our ESP8266-12E. Then we select it, and we can see here it will change from Arduino Uno to Node MCU ESP12E on COM7. And for sure you have to, depend on your COM, depend on which COM it will be detected on your PC. Okay, so first of all, today we will learn just to blink the built-in LED. So we come here to define the mode of the built-in LED underscore built-in. We set it as output. Okay, and then in the loop we just trigger it on and off. But be careful, the built-in LED of the ESP8266 is active low. So it means if you want to turn it on, you have to send low or 0. So we type here digital write to the built-in, LED built-in, not built-in, LED built-in. Okay, 0. So this one will turn it on because it's active low. Then we wait for, let's say, 2 seconds. Then again we turn it off. Digital write to the LED built-in 1. Okay, this one will turn it off because it's active low again. And again we add a delay of 2 seconds. Here we go. Okay, so now I'll connect it to my computer. Here we go. So now if I check, yes, it's on the COM7, then I will upload it. Okay, here we go. We can see it's communicating and it's writing. Then later I'll show you how it's writing to the board. Okay, it's 8%. It might take some time. Okay, done. So if you can see here on the board, later I'll show you, it's already blinked in.
Okay, as we can see here, so you can see now that the UART module or USB to UART module is trying to talking to the Wi-Fi module. Okay, you see now it's transmitting, and the ESP is sending back the acknowledgement, and here we go, it's finished, and we can see now the LED is blinking. Okay, so now we can go back and continue the rest of the tutorial.
Okay, so now again, we'll come to add more functionality to our code. We will try to add the serial print. So in order to use the serial print, first we have to initialize it by using serial.begin with the baud rate. Let's really use 9600. Then here we will try to print some comment to the serial port. Let's say serial.print line LED is on. Then let's just copy it. LED is off here. Okay, so this one we just use it to print some data on the serial monitor. Okay, again we upload. Okay, it's compiling. Should be everything okay. Yes, compiler is happy. Now connecting. Okay, good. So now start communicating with the ESP. Okay. Here we go. It's done already. And you see the nice thing is after we compile, after it's downloaded and everything, okay, no need to refresh, no need to disconnect the power, then you reset all the GPIOs and you run again. This one actually it will done automatically thanks to the circuit we saw it before. Then now if we open the serial, there we go. We take out this. Open again. Yes, here we go. LED is off. LED is on. LED is off. LED is on. Okay. So later I will show you also how it's work on the breadboard. But yeah, so with this very simple basic tutorial, if you successfully done all this, so you can make sure that the circuit is working, the ESP is successfully being programmed. But you have to make sure, please take a note on this, if you already upload any sketch to your ESP8266 and it's running, you will lose the AT comment functionality. It means you cannot access the AT comment anymore. Okay, you cannot use the AT functionality. If you remember, or if you're aware about this, you can use the AT command, the attention command, that you can say AT, then it will reply with OK. Then you talk to the module with the different commands. This one will not be active anymore because you override the firmware. Then you need to re-burn the firmware inside the ESP8266. But this one, I believe it's more than, it's more convenient to use the real coding directly inside the ESP instead of just use the AT command to do your required code. Okay, so we have reached to the end of this tutorial. I hope you have learned something new regarding the ESP8266. Although it's very basic, but believe me, if you reach this point, then you can do much more in the future. And in the future, I will going to do more more fruitful tutorials with the ESP8266 to build more client server and, let's say, chat coding with these modules. So stay tuned for this, and thank you.